Hello everyone. So today we are going to discuss about heat treatment. This is second model of the course. So we know our course is materials and technology. So second model is heat treatment. Why you want to study the heat treatment? What is the use of studying the heat treatment? When they will do? So heat treatment is nothing but after doing any process like casting or any other type of processing like manufacturing process. After that, if you want to increase the physical property or microstructure, generally if you want to change the microstructure, why they want to change the microstructure? If you want to change the microstructure, obviously strength and hardness, ductility, toughness, everything will change, that, especially the mechanical property. For that purpose only, heat treatment generally will do. So in this chapter, we are going to discuss about what are the basic principles of heat treatment, hardening, annealing, normalizing, hardening process, and the thermochemical processes, and tempering process, and martembering, martembering and astempering process. So these are the steps we are going to discuss here. First, basic principle of heat treatment. Why you want to do the heat treatment? Heat treatment of the metal, generally they will do for only metal. We can't do for the non-metal things here. And heat treatment of the metal or alloys is a technological procedure including controlling the heating and cooling operation. If you are doing the process heating very fast or very slow or normal, and if you are doing the cooling rate is very slow or high or medium, that depends on the heat treatment taking place and conducting for the purpose of changing the alloy microstructure. Generally, they will do, I already told you, uh, microstructure changes and resulting actually the required properties. Generally, for the physical property or mechanical property, through the mechanical property, they will do this process. And there are two general objectives of the heat treatment. One is hardening and annealing process. So first we'll discuss about the hardening process. What is hardening? Hardening is the process of increasing the metal hardness, strength, toughness, fatigue, resistance. What is strain hardening? Generally, they will call work hardening also. Strengthened by cold working. So there are two type of workings: the cold working and hot working. If you are doing the process under the room temperature, that is cold working. If you are doing the various temperature like above the room temperature, that is hot working. And cold plastic deformation cases increase the concentration of dislocation, which mutually entangle one another, making further dislocation motion different, uh, difficult, and therefore resisting the deformation and increasing the metal strength. If dislocation is more difficult, means the movement of the fracture is or structure is very less, so strength will be increasing automatically. And grain size strengthening, like hardening, strengthening by the grain refining. If you get the fine grain using the cold working, means different coating processes. So that time also you can able to get the high hardening. And grain boundary serves as a barrier to dislocation, raising the stress required to process the plastic parts. If a grain boundary is if a grain is very small, so when you are applying the any force or if you are doing the heat treatment, that crossing or dislocation, getting dislocation is very difficult. But if your grain size is big, so easy to dislocate, easy to move one grain to another grain. That's why if you have bigger grain size, strength is less, but ductility is more. But if you have fine grain structure, if you will get high strength and low ductility. And solid solution ordering. I already told what is solid solution. When two different metal adding for alloying purpose, when you are seeing using the microstructure, it should look like a single or like pure alloy structure. How it will be appear like that? It should appear in the microscope. That is solid solution. So in that solid solution, how we are equal the order of strengthening by the dissolving of alloying elements. Atoms of the solid element destroy the crystal lattice and resisting the dislocation motion. And interstitial elements are more effective in the solid solution order than the substitution element. Why? It's like interstitial element is more because this is in liquid state. Mostly substitution element will be available in the solid state, fully solid state. And this dispersion strengthening, strengthening by the adding second phase into the metal matrix. That time dispersion strengthening will take place, and second phase boundary resists the dislocation motion, increasing the material strength. And strengthen effect may be significant if fine hot particle are added into the soft ductile matrix like composite material. See, if you are using like aluminum composite, adding some iron particles like any other hard particle like titanium, magnesium. So that time this kind of problem is taking place. And hardening by result of sphenoidal decomposition. The sphenoidal structure is characterized by the strain on coherent boundary between the sphenoidal phase causes hardening of the alloy. If you do the hardening of the alloy, I already told, you can increase the strength, tensile strength and fatigue property and precipitation from the supersaturated B solution occurred in the several types. When precipitation takes place, when you are adding any element more than your quantity or more than the solubility level or it's not acceptable, that is precipitation takes place. So segregation of copper atom into plain cluster. Those clusters called as the Junior Personal Zone. Generally they will call GPI1 zones. And diffusion of copper atom to the GP1 zones and formation of larger cluster called as GP2 zone or theta base. This base is co-current with the matrix. The formation of a theta phase which is partially coherent with the matrix. This phase provides maximum hardening. So what is annealing? This is the third type of hardening method. Annealing is a heat treatment procedure involving heating the alloy and holding it on the certain temperature. Annealing temperature is called as controlled by cooling. Say for example, annealing generally when you are heating or doing the process using the any furnace, they will keep it in inside furnace only. Automatically when furnaces come down the room temperature, that until that this process will take place. Annealing result in the relief of internal stress, softening, chemical homogenization, and transformation of grain structure into more stable state. Say for example, when you are doing the casting process, there are different method of casting process. Depends on the casting process, you will get the microstructures. When you are doing the annealing process, internal stress due to the different type of casting method, stress will be there. So that will get relief first and softening. So when you are heating the any metal surface, it will go to under the softening. And chemical homogeneous means structure of or composition of the element will be uniform throughout the structure. And transformation of the grain structure into the more stable state. So when you are doing the casting process, there are many defect or inhomogeneous microstructure. But when you are doing the homogeneous, heat treatment, structure become a more stable state. What are the stages, annealing stages? So first is stress relief, a relatively low temperature process of reducing internal mechanical stress caused by cold work or colding or welding or casting they will do. And during this process, atom move to more stable position in the crystal structure, and vacancies in the interstitial defects are eliminated and some dissolution are also annulled. See, for example, while doing casting process, say for example, if you take the steel means made of iron and steel. So there are standard iron atoms and iron and carbon. Iron atom and carbon atom should arrange in such a manner. But due to the different casting process or any manufacturing process, that arrangement will be not in the correct position. But when you are doing the heat treatment, the arrangement of the atom will be good. And this time, not only the arrangement, if you do arrangement is proper, the vacancy and the interstitial defects also automatically eliminated. And dislocation also annulled. And discover the heat treatment is used mainly for preventing the stress corrosion cracking and decreasing the distortion and gases by internal stress. So to avoid such kind of like stress corrosion, cracking and different distortion due to the internal stress, it will happen. So to avoid that kind of thing, they will do the annealing and recrystallization. It's like alteration of the grain structure of the metal. These are the reason we are doing the annealing process. If the alloy reaches the particular temperature, like recrystallization temperature, new grains start to grow from the nuclei formed in the cold earth metal. The new grain absorb infiltration on the distortion caused by the cold work. These grains are eukaryotic and independent to the old grain structures. You cannot able to mix with the old grain. The property of the old grain and new grain is totally different. And grain growth, over annealing and secondary recrystallization. So if you are doing annealing process for more time, the growth of new grains at the expense of the neighbors occurring at the temperature above the recrystallization temperature. This process results in coarsening the grain structure and also it's undesirable. So if you keep on doing the annealing process, the grain structure will be bigger size and also in undesirable. What purpose we are doing annealing? Heat treatment for increasing the strength and hardening. If you will increasing the grain structure, how strength and hardness will take. So that's why it's called as undesirable. So softening process. There are different softening processes. The heat treatment is the control heating and cooling of the metal to alter the physical and mechanical property without changing the product shape. So here we are not going to change any shape. Pipe means pipe, rod means rod, cube means cube. We are not going to change anything. And heat treatment is sometimes done inadvertently due to the manufacturing process that either heat or cold metals such as welding or forming. So this is also possible. So it depends on your manufacturing process. There are variety of different type of manufacturing processes. Each process causes a different defect. To avoid that, we are going to do the different type of heat treatment. Heat treatment is often associated with increasing the strength of material, but it can also be used for alter the certain manufacturability objects, such as improving machining, improve the formability, restore ductility after the cold working operation. But it is very enable manufacturing process that cannot only help other manufacturing process, but can be also improve the product performance by increasing strength or other desirable characteristics hardening, tensile and toughness, and maybe the ductile chapter material. And steels are particularly suitable for the heat treatment since they respond well to heat treatment, and the commercial use of steel exists that of the any other material, and steels are heat treated for one of the following reasons. What are the reasons? See, if you compare with other material like titanium or aluminum, copper, that most of the case steel alloys only generally we will do the heat treatment. First reason is softening. Softening is done to reduce the strength and hardness, remove the residual stress, improve the toughness. Where you want to use the tough, that time they will use the softening process and restore the ductility, improve the ductility power and refine the grain size, change the electromagnetic property of the steel, and restoring the ductility and removing the residual stress is a necessary operation when a large amount of cold working is to be performed, such as in a cold rolling operation or a wire drawing. And annealing is the full process and periodizing, normalizing, tempering, astempering, matempering, or are the principal way by the which steel is softening. And hardening. Hardening of the steel is done to increase the strength and wear property. One of the prerequisites for hardening is a sufficient carbon and alloy content. If there is a sufficient carbon content, then steel can be directly hardened. Otherwise, surface of the part has to be carbon enriched using some diffusion treatment hardening technique. Okay, if your carbon amount is less, you have to do the some subordinate process and material modification. How they will do the modification? Heat treatment is used to modify the property of material, like in addition to hardening and softening. Those processes modify the behavior of steels in the beneficial manner to maximize the life. Example, stress relieving or strength of property. Example like cryogenic treatment or some other desirable property like spring agent. And what is annealing? Used variously to soften, relieve internal stress, and improve the machinability and develop a particular mechanical physical property. See, we already discussed that annealing process. Here, we are discussing why we are studying the annealing to improve the machinability. If the machinability is not there, if you are manufacturing some product here, you are sending it to somewhere abroad, there's some defect they are finding. If they are not able to remove that defect, means like surface damage or surface crack or anything, small one. If it's like we are able to change the remove that unwanted particles. It's easy to machinable. And in the special silicon steels used for transformer lamination, annealing developed to the particular microstructure that confers the unique electrical property, and this is using for the electrical application also. Annealing requires heat to above a temperature, holding for sufficient time for the temper utilization followed by flow cooling. And stress from the forming operation can affect both rimfire and centrifugal cartridge cases. For many cases, especially those with bottlenecks, the stress are so great that high temperature annealing must be used. After forming a bottleneck case, many appear perfectly servable. Our massive stress are like to remain in those areas. If ammunition is loaded and stored without address those stress, crack can appear in the bottleneck area. You can able to see this. And case bottlenecks are normally flame annealed by following the process. What are the process? placed on the moving rail or rotatory disc system. This case passes before set of gas burner that rapidly heat the neck and shoulder area to glowing. As the beginning incandescent, the brass grains grow larger. The heated area of the case is immediately tipped into the water bath to quench the case, establishing a large grain structure. The heat treatment causes a dark but harmless discoloration to the neck area. The commercial ammunition, this dark area may be polished out for the cosmetic reason. In US military ammunition, the discoloration remains visible. The application of heat treatment technology to vary the grain structure gradually from small grains in the head area to large one at the case mouth determine case hardening. All the pressure, high pressure cases must have variable metrological property depends on the part of cases as follows. On his head must be tough, relatively unyielding, small brass grains contribute to the toughness. This is the reason. And now, fourth process is normalizing. Also used to soften and relieve the internal stress after cold weather and to refine the grain size and metallurgical structure. It may be used to break up the dendritic a cast structure, casting to improve their machinability and future heat treatment response or to mitigate banding in rolling steel. This requires heating to above a certain temperature, holding for sufficient time to allow temperature regulation followed by air cooling. It is therefore similar to annealing but with a faster cooling rate. Curve 3 and figure 1 would be the normalized structure. And fifth one is the hardening processes. What is hardening? The process is steel which contains sufficient carbon and whereas other alloying elements are cooled or quenched sufficiently rapidly from the above transpiration temperature to produce mercantile. The hard phase already decided. See curve 1 and 1 in the figure 1. There is a range of quenching media of varying severity, water or dry being the most served, and through the oil and synthetic products to air, which is least service. So you can ask, where is the figure? You are always asking the figure curve and done. I will show you in the class detailed way. Here, if I start, it will take much time. That's why I am not able to show here. So, what is tempering? After quenching, the steel is hard, brittle, and internal stressed. Before use, it is usually necessary to reduce those stresses and increase the toughness by tempering. So if you are doing tempering, toughness will increase. There will also be a reduction in hardness and the selection of tempering temperature degrades. The final properties. The tempering curves, which are plots in the hardness against temperature. And processing method. There are different processing methods available for the in the past thermochemical processor carried out by the pack cementation or salt bath process. Those are now largely replaced on product quality environment grounds by gas or plasma techniques. The exploration of fluorinizing this for which is a safe production scale, gas is flowed has yet to be developed and pack cementation is likely to be remain and the only viable right for some time to come. The gas processes are usually carried out in the now almost universal steel quench furnace and any subsequent heat treatments readily carried out immediately without taking the work out of the furnace. This reduce the handling, is the cost and as, as well as quality benefit. If you are not removing your sample from the furnace until it's taking the normal time and cooling, and then process will take much time. But while after heat treatment, if you take out from the furnace, the damage and quality will reduce. Sorry, increasing the damage of the product will be more and quality, reducing the quality. Techniques and practice. As we have already seen these techniques, heating to the above set temperature, holding the equalize the temperature that and then slow cool. If this is done in air, there is a real risk of damage to parts by decarbonization and of course acceleration. It is increasingly common to avoid by bright or close annealing using productive atmosphere. The particular atmosphere chosen will be depends upon the type of steel. Normalizing. In common with annealing, there is a risk of surface degradation, but as air cooling is common practice, this process is most often used as an intermediate stage 2 followed by machining and acid pickling or cold working to restore surface integrity. And finally, the hardening, which many component. Hardening is the visual, the final process, and great care must be taken to protect the surface from degradation and decarbonization. The seal points. The furnace is now industry standard to carbon, low and middle alloy carbon steels. This work is attached, protected at each stage by specially covered atmosphere. Some tools benefit from the vacuum hardening or tempering. Salt bath were widely used but are losing favor on environment grounds. So seventh one is tempering. Tempering is the essential after most hardening operation to restore some toughness to structure. It is frequently performed as an internal pressure part of the glass and with partially fully protect against oxidation and degradation throughout the process. Generally, the tempering is conducted in the temperature range 150 degrees Celsius to 700 degrees Celsius, and also it depends upon the type of steel, and this time is depends upon the microstructure changes occur relatively slowly. Occasion means tempering can in some circumstances make the steel brittle, which is opposite of the what is intended to achieve. There are two forms of this brittleness. One is temper brittleness and blue brittleness. Temper brittleness is like happen 375 degrees Celsius to 575 degrees Celsius. And blue brittleness is affect the carbon and some alloy steel after tempering the range from 230 degrees to 370 degrees Celsius and rapidly cooling. This is the process. And in now metallurgical department about the sustainability of the steel type, the necessity of heat treatment for any application, and more tempering or astempering. It will be rapidly appreciated that quenching operation is used in hardening introduce interest test into steel. Those can be sufficiently large to destroy or even crack the steel. More tempering is applied to steel sufficient hardenability and involves an isothermal hole in the quenching operation. This allows temperature equalization across the section of the pot and more uniform cooling structure and hence lower stresses. The steel can be tempered in the in the way. So here I am going to stop about the tempering process. I hope you guys are understand what is tempering, how it is useful in industry.